It's extremely important in the field. If you are going to dismantle the pump, you only dismantle from the fan shroud side. Never dismantle from the pump pulley side. I'll show you how to dismantle the pump shroud side. Some small screws hold the shroud on. The shroud end comes off. Shroud body comes off. The air fan comes off by removing these set screws, 2 set screws. Sometimes, if the pump's been in use for some time, rust builds up. So attempt to clean that as best you can. A pulley may be required to pull the fan off. Because the aluminum fan, aluminum on steel, sometimes gets very sticky, we may need to use a puller to pull the fan off. Simply use your puller. It pops the fan off. Clean the shaft and rub your hand around it and make sure that there's no sharp edges. Clean the shaft as best as you can, because in here there is a seal and we don't want to damage the seal. So any sharp edges that have developed on the shaft, can take a piece of emery cloth and clean the shaft. Now I'll show you how to disassemble this cap side. So we start by removing the screws. There's a series of longer screws that I've just taken out. There's 2 screws here that are very short screws. I'll show you why. This short screw, as you can see, substantially shorter than these other ones. So what you do when you have those out, you take 2 long screws, you screw them into the port where the short screw came out, and that acts as a puller to pull that plate off. So do it slowly. As you can see, the plate is coming off. So go from side to side, again slowly. Now when you get to this point, there will likely be fluid run out of the bottom of the pump. So protect the area from the fluid that flows through. So once this is loose, you can remove these screws. And this cap simply slides off. When you're doing that, keep an eye on this seal and make sure you don't damage the seal. So now we've exposed the inside of the pump. We have 3 veins. That's why they call this a rotary vane pump. The center of the shaft is not center of the body. It's eccentric. So what happens when the pump is rotating this way is the vane will get to top dead center and will be totally recessed into the vane port. As the pump rotates, rotation is this way. As the pump rotates, centrifugal force forces the vane out. It touches the body, rotates, and by the time it gets back to top dead center, it slides back into the vane carrier port. So it's a continuous movement of the 3 veins going into the port and coming out of the port and following the wall. That rotation creates all the airflow to activate the pump. In some cases, if you are dealing with certain types of fluids or mist or solids, these veins may stick in there and not be able to move freely up and down in the vane port. The indicator for that is the pump will make a hammering sound. So in order to have a look at the veins and see what the issue is, you'll need to do this process of removing the shroud, the fan, and the end cap. And then you can simply see and test by moving the veins up and down. Sometimes if the veins get wore, this is what a new vein should look like. You simply take a file down the worn area, rotate the vane, and slide it back in. At times, you'll need to ensure that this pump is clean, the inside of the pump body. So with your hand, check the wall to make sure that there's no deep grooves in the wall. If it's simply just a matter of replacing the veins, we simply pull the veins out. Once we remove the old veins, you'll want to make sure that a thorough cleaning of the inside of the pump body is done. So just using solvent, like a Varsol type of a solvent, soak a rag and just use the rag to clean out the inside of the pump body. To clean the vane ports, we simply use a brush, again, dipped in solvent, push it down, and just move it back and forth and ensure that those are clean. You can take compressed air or rags or spray bottle with the solvent in it, spray it good, just ensure that it's clean, and it gives you an opportunity to check the wall on the body itself. Once the cleaning of the inside of the pump is done, you'll want to replace the veins. One indicator to tell whether your vane ports are clean is the vane should move freely in and out of the vane port. So, replacing the veins. Quite simply, nice and clean, veins move freely. That's a clean pump body. And simply replace the veins with new veins. See how easily the new veins slide in. Rotate the pump. Slide all veins in. Ensure that they move freely. Rotate the pump by hand to access the other vein, and out it comes. Simple to replace the veins. As you can see, the rotation of the pump pushing the vein down into the vein port and allowing the vein to slide up against the wall, and we have a continuous flow as centrifugal force rotates. Bearing in mind when the pump is operating, the nominal rotational speed is 1,000 RPMs. So once you have your body cleaned, your new veins in place, simply reverse the procedure and assemble. With a tube of high temperature gasket material, ensure that it's high temperature. We simply create that liquid gasket. Once the liquid gasket is in place, ensuring that we don't fill these holes with the liquid gasket material, we replace the plate. When you're reinstalling your bolts, in order to get them lined up with the holes properly, you may be required to lift up on the shaft a slight bit. Simply tighten the bolts in. Ensuring that you don't over-tighten. Make sure that your small bolts go back in to the small bolt ports, which you'll notice there are threads for the small bolts on the cap itself. So it's easily to determine which holes the small bolts go into. When reinstalling the fan blades, ensure that one of the bolts line up with the groove in the shaft. Recess it back from the edge of the shaft, approximately 1/2 inch, with the thickness of a screwdriver. Tighten the bolts. Replace the shroud assembly, and the pump is ready to work again.